morning. My name is Nick Lyon, and I am with MBNI Consulting. We are here today to present our findings regarding the Just Another Police Department's police officer selection system. Our mission at MBNI is to provide our clients with effective solutions for all aspects of human resource management by developing and implementing scientifically proven methods to contribute to the attainment of organizational and individual success. Our organization was founded in November 2021 and is locally owned and operated out of Fairfax, Virginia. Our areas of expertise include the development and application of psychology principles and research methods to improve overall work environment, including recruitment and selection, performance, communication, professional satisfaction, and safety. Our team assigned to this project includes Mandana Tadion, who has an expertise in data analysis and employee selection; Bailey Middleton, who has an expertise in technical writing and editing; Ian Hamilton, with expertise also in data analysis and consulting; and myself, with expertise in technical writing and management principles. All 4 team members assigned to this project have obtained an MPS in Industrial and Organizational Psychology from George Mason University in Fairfax, Virginia. JAPD has contracted with MBNI Consulting to review the current personnel selection system for the position of police officer and make recommendations on the development of a system that is valid, predictive of future success, and legally defensible. Through a multi-phase approach, we will conduct a comprehensive review of the selection system by conducting a job analysis, validity analysis, and utility and legal analysis, ultimately resulting in recommendations for JAPD related to this selection system. I will now turn this over to Mandana, who will discuss Phase 1 of this process, the validity analysis.
Thank you, Nick. So in the first phase of the project, we assessed the validity of the selection methods that JAPD is currently using to determine if there is a relationship between any of the selection methods and superior work performance. In other words, we determine whether or not the current selection system, or our predictors, measure employees' performance accurately. It's generally beneficial to utilize more than one predictor in a selection battery with the hope that certain constructs that are not being measured by one predictor may be measured by another. However, we also need to be wary of intercorrelations, which is when some of the predictors are measuring the same construct, in which case we choose to keep the strongest predictor among them and eliminate the rest, which saves time and money for the organization. To do this, we first measured the power of each predictor alone and then in combination with the others. Table 1 shows the independent validity coefficient for each selection method or predictor. As you can see, the general mental ability test has the highest correlation, meaning that it is the strongest predictor of performance. However, all 4 predictors, when measured individually, show to have statistically significant relationships with performance, which means that they can all predict successful performance to a certain degree. We then combined different predictors to find the most effective combination when intercorrelation is at play. We conducted data analysis on all the possible combinations of predictors to analyze and determine the most effective combination. In Figure 1, you can see that if we use the general mental ability test as a predictor alone or in combination with other predictors, we have almost the same amount of variance percentage, which indicates how well the variation in our selection methods explain the variation in performance. I should point out that this number drops to half when we remove the general mental ability test from the selection battery. So to summarize, after the general mental ability test, the predictive power of any additional selection measure is marginal. So JAPD can potentially eliminate 1 or 2 of the remaining selection methods and still keep the validity of its selection process at the same level. But before we start making decisions, we also need to consider the utility of the current selection method, as well as an in-depth analysis of the fairness, bias, and legal aspects, which my colleague Ian will discuss next.
Thanks, Mandana. We measure the utility of a selection procedure by the success rate of the hired employees. Success rate is defined as the proportion of selected candidates who prove to perform successfully once hired. The Taylor-Russell model which you can see on the slide below, illustrates how the interaction between the selection ratio, base rate, and validity affects the success rate. The success rate will vary depending on the combination of predictors that make up the selection battery that JAPD ultimately chooses. We chose to calculate the success rate of a selection battery that uses all 4 predictors for the purpose of this presentation. That includes GMA testing, interviews, in-basket tests, and job knowledge tests. According to this Taylor-Russell table, when a selection system has a base rate of 0.5, meaning half our candidate pool possess the necessary KSAs, a hypothetical selection ratio of 0.5, meaning we will hire half of the candidates that apply, and a validity coefficient of our selection process, which was found to be 0.254 in Phase 1, we can estimate that 58% of the people hired will be successful at JAPD. In Phase 1, Mandana showed that GMA tests are the best predictor of performance, but this method has been proven to adversely impact minority subgroups. To ensure that the selection battery that we will recommend is fair, legally defensible, and valid for both white and black applicants, we ran statistical analyses to determine the adverse impact of 3 different selection batteries at 3 different selection ratios and calculated their differential validity. In examining adverse impact, our team at MBNI compared the selection of the white and black group of applicants because according to the Uniform Guidelines on Employee Selection Procedures, if selection ratios for one subgroup are less than 4/5 or 80% of the selection ratio for the group with the highest selection ratio, this is evidence of adverse impact. In JAPD's case, black applicants were selected less frequently than white applicants. For this reason, as an example, an adverse impact ratio of 0.25 indicates black applicants would be selected 25% as often as white applicants, which is well below the legal minimum of 80%. Now that we understand what this table is telling us, if you look at the table, it's clear to see that the adverse impact ratios for selection battery number 2, which does not use the GMA test as a selection predictor, are closer to the 0.8 legal standard at selection ratios of 0.1 and 0.5. At a selection ratio of 0.1, the other 2 selection batteries produce adverse impact ratios that are much lower than the adverse impact ratio of selection battery number 2. At a selection ratio of 0.5, the selection battery number 1, which included all 4 predictors, yielded a slightly worse adverse impact ratio than selection battery number 2. The table shows that all 3 selection batteries were not discriminatory at a selection ratio of 0.9, which means that JAPD would be accepting 90% of the applicants who apply. Diversity and fairness considerations need to be weighed against the validity of each battery. The selection batteries with the highest validity all include GMA testing, so excluding it will decrease the predictive power of our selection procedures. We discuss these considerations in more detail in our recommendations later on in the presentation. The table on this slide shows that the combination of all 4 predictors found in selection battery 1 resulted in a noticeable difference between the validity coefficient of the black applicant population, which was 0.386, and the white applicant population, which was 0.529. Therefore, we conclude that this combination of predictors does result in differential validity, which means the selection test battery is not as valid for the subgroup of black applicants. The differential validity of this battery was similar to the amount of differential validity found in selection battery option number 3. The second combination of predictors, which excluded GMA testing, resulted in a smaller difference between the validity coefficients of the black and white applicant populations. Therefore, this combination appears to do the least harm to black applicants and is the fairest selection battery out of the 3 that we consider in our table. It should be noted, however, that while there is not a large differential validity in selection battery number 2, it also has the lowest validity coefficient values for both white and black applicants of all the batteries examined, which is likely because we excluded GMA testing. Lastly, the third selection battery option, which includes GMA testing and interviews, had a similarly large differential validity value to the first selection battery option, which was made up of all 4 predictors. Now I will send it over to my colleague Bailey to wrap up our presentation by providing our recommendations for JAPD based on the data generated from our statistical analyses and our collective expertise in selection processes.
Thanks, Ian. MBNI Consulting has 3 recommendations to improve JAPD's selection process. The first is to remove GMA, or general mental ability, from the selection battery. The second is to replace GMA with a different selection method. and the third is sliding test score banding. The first recommendation to remove general mental ability, or GMA, from the battery of predictors may seem strange. While GMA was originally shown to be the most powerful predictor, it does not discriminate well between candidates and thus would inform JAPD to hire roughly 90% of applicants. This shows that GMA does not have good validity and could be left off the selection battery while still retaining utility of the battery as a whole. GMA also had been shown to exhibit adverse impact, which would preclude JAPD from hiring an ethnically diverse workforce. When looking for a replacement for GMA in the selection battery, MBNI Consulting recommends replacing GMA with one of several options. The first option is situational judgment tests, or SJTs, where candidates are asked to evaluate and respond to hypothetical work scenarios. SJTs are a viable alternative to using GMA as a predictor because they have higher validity between racial demographics. The second option is assessment centers that also have high validity and little to no adverse impact. Avoiding adverse impact is going to be a key element in JAPD's selection system when hiring a diverse and inclusive workforce. Lastly, utilizing work samples would be a much more relevant way to assess a candidate's experience and qualification for JAPD. The third recommendation to improve JAPD's selection system is to use the sliding test score banding. It is a method that uses a set cutoff score and stage a range of the band. Applicants within that band are statistically equal. In the case of 2 or more applicants with scores on the same band, secondary criteria can be used. Banding allows JAPD to use GMA as a predictor while still reducing bias. The conclusion of the report details more ways to minimize adverse impact and increase inclusivity and diversity for JAPD's new hires. MBNI recommends using targeted recruiting to specifically appeal to minority candidates. In order to do this, JAPD can seek candidates focusing on academic achievements, recruit from HBCUs or minority-focused professions. Most importantly, JAPD can provide guidance for applicants in the form of internships, mentoring, and enrichment programs.
MBNI Consulting is proud to assist JAPD with this process. We would like to thank JAPD for their collaboration on this endeavor, and if anyone has any questions about anything we have discussed today, please feel free to contact us at any of the locations listed below. Thanks again.